Okay, so here we are, section 5.4, indirect proof. Um, this section is our last section on kind of how to do proofs. Um, and it's used for really situations that are kind of weird to prove directly, so to speak. And we'll talk about what that means a bit more in class. But it's something you can use to prove special relationships in triangles. We've already kind of established a lot of times informally or talked about in class, but now we'll prove it. So we've written paragraph a little bit. We've mostly done two column, and I did show you flow proofs, but today we're going to talk about indirect proofs. So first of all, indirect proof. This is known as proof by contradiction, and a contradiction is to go against something. So some people would say a contradiction would be a person that talks about how we need to help the homeless and the needy, but then themselves they never give any money to the homeless or the needy. So they're a contradiction on their own because they're going against what they've said or done. So that's how this works. You go against something you've said. So there are four steps to proof by or indirect proof. The first one, identify what you want to try to prove. Okay, what are you trying to prove that's true in the problem? So that's the first step. Identify what you're trying to prove. The second thing is you assume that statement is actually now false. Okay, so you assume that you've got something, you want to assume instead of it being true, like you're trying to prove it, you assume, no, it's false. Doesn't work. Go from there. Next, make some logical conclusions from that false statement. Come up with something. Okay. And then what'll happen eventually is you'll get a contradiction. And what it'll be is it'll be a contradiction to something that you know is given. And so we'll look at a couple proofs and you'll see what I mean by showing a contradiction, and we'll go from there. Okay. All right, so here we go. So state the assumption you would want to start an indirect proof for in the statement AB is not an altitude. So this is the part that we're trying to prove. Okay, trying to prove. So hey, I'm going to prove this is that AB is not an altitude. What would that statement have to be? Okay, so I had you try to give your answer to this one. Hopefully now we come back, you said, oh yeah, if that's what I'm trying to prove, I want to prove that it's not an altitude. I want to prove that's false. So the false statement would be that AB is an altitude. Okay. All right. Let's try another one. So I've got the statement here. Oh no, it doesn't fit. There we go. So AB, yeah, there we go. So I want to start this proof off, right? So I'm starting off saying that A is equal to 1/2 B minus 4. What would be the first statement that I would say, assuming this is false, would become? Okay, so we're back now. You have a lot of different things you could say. Basically, just as long as you don't say this same thing, you might think you're good. But really, the best one to be to prove this is false is assume that it doesn't equal 1/2 B minus 4. So now one of these proofs in action. Okay, so we want to write an indirect proof to show that if we know negative 2x plus 11 is less than 7, then x is greater than 2. Okay, so where's my screen at? So here's the deal. The first step of an indirect proof is to identify what you're trying to prove. Well, I'm trying to prove that x is greater than 2. Okay, that's the first step. The second step then is to assume this is false. If I'm going to do that, what I have to then assume is that x is actually less than or equal to 2. Okay. Now here's the tricky part about this. There are two ways I can go about this. One way is the kind of cheating way, which isn't actually mathematically correct, but now you just say, okay, well, if I'm going to assume that x greater than 2 is false, I'm saying x is less than or equal to 2. And what you do is you just pick a number that goes from this, like so x is less than or equal to 2. So I could say let x equal 0, because that's less than 2. And what you just do is you plug it in for x up here. Negative 2 times 0 plus 11 is less than 7. 11 is we get 0 plus 11 is less than 7, and 11 is not less than 7. There's what we call the contradiction. That's false. So what that means is, oh, this doesn't work because this was false, so x can't be less than or equal to 2. It must be greater than 2. That's kind of the cheating way to do it. The true way is to do this. All right, so take the statement we know that we're now going to try to prove is, that we assume is true. X is greater than or equal to 2. What I want to do, and this is the tricky part, is algebraically, I want to turn this statement into something that looks like this. So the first thing I notice is, hey, x is multiplied by negative 2. So multiply both sides by negative 2. Okay. That gives me then negative 2x is less than or equal to negative 4. However, that's wrong, because remember back in Algebra 1 we said, hey, if you multiply both sides by negatives, to solve, you actually have to flip that symbol. So that's why that's tricky, as a lot of people wouldn't think to do that. Then we have to get it to be negative 2x plus 11, so add 11 to both sides. Okay, so our statement then becomes negative 2x plus 11 is greater than or equal to, well, negative 4 plus 11 is 7. Right here is our contradiction mathematically. What's the contradiction? Well, we were told in the very beginning that negative 2x plus 11 is less than 7. But if I assume that x is less than or equal to 2, I actually get that negative 2x plus 11 is greater than or equal to 7. And that's false because this was what we know is true. Okay. So since this is false, therefore x must be greater than 2. Now the algebra ones are really the most difficult ones to do. The geometry ones are the ones that make a little more sense. So we'll look at both in class, but for the video's sake, we started with an algebra one. So now here's a geometric one. Given triangle ABC, prove that a triangle has no more than one right angle. Okay, so that's what I'm going to prove. Whoops, wrong button. Gosh dang it. Here we go. So here's what I'm going to do. Now again, by proof by contradiction, I've already done the first step. I've got the proof part of it. Step 2 is assume this is false. You're going to assume that triangle ABC has no more than one right angle. Assume that's false. Okay, now we're back. Hopefully you said the false statement would be that triangle ABC has more than one right angle. Okay. Now, there's one more thing to this we have to add though, because we have to find somewhere that's a contradiction. So we have to talk about another fact we know. If this is a triangle, then angle A plus angle B plus angle C has to equal 180. That's a truth for triangles, that all three angles added together is 180 degrees. So here's what we're going to say. All right, assume ABC has more than one right angle. So let's assume it has 2. Has more than one angle. So let angle A and angle B be right angles. Okay. Well, the problem that happens then is if I say, okay, add A plus measure of angle B plus measure of angle C, okay, we're going to add them together, they should equal 180. Well, here's our problem. If A and B are both right angles, that means 90 plus measure of angle C equals 180. Okay. Well, 90 plus 90 is 180. When I subtract 180 from both sides, I get the measure of angle C is 0. That can't happen. That's got to be false. You can't have an angle in a triangle that's 0 degrees. So since we get our false statement, there's our contradiction. Therefore, and this would be step 3. Step 4, a triangle has no more than one right, angle. Okay, there we go. So just to kind of reiterate over again. Okay, how indirect proof works is you identify a statement you want to prove is true. You assume that statement's false. You make some logical conclusions from a false statement, and then you'll find a contradiction in the problem, which a false statement, which then makes the first statement true. Okay. So, if you have any questions, come in. We can talk. Otherwise, I'll see you in class tomorrow.